This video is going to cover the 5-2 warm-up and then the 5-3 notes. So if you'll pause the video and allow everybody enough time to work on the warm-up, maybe about 5 minutes, and then unpause it so that we can continue to go over it. All right, so in 5-2, we talked about our perpendicular bisector, and that's what all of this warm-up is pertaining to. The first question says, in exercises 1 and 2, find the length of AB. So if you look at 1, B, or this ray here that's missing, that doesn't have another letter, so that ray is the perpendicular bisector to AC, and we know this because it meets at a right angle and the 2 congruency marks, and then any point that lies on that bisector, in this case B, would be equidistant from the endpoints of the segment, which means that 3x plus 1 equals 4x minus 7. Subtract the 3x. Add the 7. And I get x equals 8. But it's asking for AB, so I want to take that 8 and I want to plug it back in to AB. 3 times 8 plus 1. 24 plus 1, which is 25. I can always check it by plugging it back in there as well into the BC, or plugging the 8 into here and making sure you get the same answer, because again, they should be the same value. Okay, now if we look at number 2, it says that CB is 5x plus 7 and BA is 7x. Again, this B lies on the perpendicular bisector of AC, which means it's equidistant from the endpoints of that segment. 5x plus 7 would equal 7x, which means 7 equals 2x. X equals 7 over 2, or 3.5, or 3.5. Any of those answers would be fine. But when we plug it back in to get A, and it's 7, I can multiply this by 7 over 2, or 7, 3.5. This would be 49 over 2, which you can leave that way, or you can continue to work it out. It'd be 24.5, which is what you would get from here, 24.5. So again, any of those work. As long as it's a reduced fraction, even if it's improper, it's okay. Okay, number 3 says, in this diagram, the perpendicular bisectors of ABC meet at point G. Find EC, and GC. So what we learned yesterday is that this point is called a point of concurrency, and specifically in a perpendicular bisector, it's called the circumcenter. And the theorem we learned about this is that the circumcenter is equal distance from the vertices of my triangle. So if that is 7, then both GC and AG would be 7. So that's that one. And then EC is equivalent to BE, because if it's a perpendicular bisector, it meets at its midpoint, which means EC is 5. Okay, so today we're going to look into Chapter 5, Section 3, which is angle bisectors of a triangle. So we've talked about mid-segments, we've talked about perpendicular bisectors, and now we're going to get into angle bisectors. The angle bisector, which we already know the definition of an angle bisector, which is a ray that cuts an angle into 2 congruent parts. So if a point is on the bisector of an angle, then it's equidistant from the 2 sides of the angle, is the angle bisector theorem. So again, it has a name. You can use that name, or you can write the entire thing out if you're trying to justify a statement. So in this diagram, it says, if ray AD bisects angle BAC and DB is perpendicular to AB. So this is what's important here, is that these segments that are connecting the point on the angle bisector to the ray must be perpendicular. Remember, that's how we show true distance. So those have to have a little right angle. If that's the case, then BD is congruent to BC. But again, it has to have the right angle to show the distance away. The converse of the angle bisector theorem says the reverse of that. It says if a point is in the interior of an angle and it's equidistant from the end point, or from the sides of the angle, again, you have to have the congruency marks and the right angle, then it lies on the bisector of the angle. So in this case, if DB is perpendicular to AB and DC is perpendicular to AC, and we know that because of the right angle marks, and DB is equal to DC, then AD bisects angle BAC. And the theorem that is the concurrency of the angle bisectors of the triangle says the angle bisectors of a triangle intersect at a point that's equidistant from the sides of the triangle. So just like with perpendicular bisectors, we have a point of concurrency. This time it is equidistant from the sides of the triangle. So these little blue lines show the distance from that point to the sides of the triangle. And in this case, they would all be congruent. So PD would equal PE and PF. The incenter is the point of concurrency of the three angle bisectors of a triangle. So the incenter is that point of concurrency. Remember with the perpendicular bisectors, it was the circumcenter. And now we add the incenter for the angle bisectors. If you also remember with the perpendicular bisectors, these were in different locations. If it was acute, they were inside the triangle. If it was right, they met on the triangle. And if it was obtuse, they met outside the triangle. For the incenter, or the point of concurrency for the angle bisectors, it always lies inside the circle. So no matter what kind of, inside the triangle. No matter what kind of triangle you draw, they will always meet inside the triangle. And how we word this is that the circle is said to be inscribed within the triangle. So whatever's inside the triangle is inscribed, and whatever's on the outside is actually said to be circumscribed about the circle. All right, so example 1 says find the value of x. Here I've got my right angle marks to show true distance. I've got 27 and 27 to show that this angle is being bisected, which means x equals 15. Example 2, again, this time you've got the right angle marks, but what's different is that instead of showing that the angles are congruent, we're showing that these segments are congruent, which means the point here is equidistant from the sides of the angle, making this the angle bisector. So 3x plus 5 would equal 4x minus 6. Subtract the 3x. Add the 6. And x is 11. So this is the converse. And the last one, find the value of x. This time again, you've got the angle congruency marks, which says that this ray is the angle bisector. You've got the right angles on these blue sides, which shows that those are true distance, which means 5x would equal 6x minus 5. Subtract the 6x. Negative x equals negative 5. Multiply or divide by negative 1, and x equals 5. All right, so you can use the remaining time in class to work on the 5-3 homework. There's also a Quizlet available that covers 5-1 to 5-3, so you can start practicing your vocab and your theorems for that quiz, which is going to cover 5-1 to 5-3. And don't forget to submit your notes today, the warm-up and the notes in all one file. Have a great day.